Derivatives of inverse trigonometric functions. This is continuing sections 2.6 and 3.6. And we want to do a little bit of review first. The arcsine, arccosine, arctan functions are defined as inverses of the basic trigonometric functions. So let's see, this is a right triangle. Theta is this angle. The ratio opposite over hypotenuse is the sine of theta. Adjacent over hypotenuse is the cosine theta. And opposite over adjacent is tangent of theta. Now, what is arc sine O over H? That is, we're basically arc sine takes a ratio and gives out, spits out an angle. And so arc sine of O over H is going to be, and then arc cosine A over H, which was the cosine of theta. Arc cosine of the ratio is theta. Arctangent of O over A is theta as well. Warning, do not confuse arc sine theta with 1 over sine theta, and that's cosecant theta instead. And also remember that the graph of sine theta, cosine theta, tangent theta, they do not pass the horizontal line test. That means that they're not one-to-one. Therefore, in order to define inverse functions, we must restrict the domain. Now, next page is about that. So let's say domain of arcsine is x between -1 and 1, which is the range of sine function. But range of arcsine is only limited to -π½ to π². So if I don't have the entire wave going vertically. Arc cosine is between -1 and 1. X domain of arc cosine is between -1 and 1. But range is between 0 and pi. Arctangent, x is between -infinity and infinity. That's the domain. Range is between -π½ and π², and that's the shape of the arctangent, and that we have to memorize because the horizontal asymptotes are important in the problems that we are going to see. Again, review from pre-calculus. It's important a lot of times. If we're calculating an angle whose tangent or sine or cosine we have, and we want to find the other ratios for it. And so how do we do that? Of course, using the inverse. Expressing it with the inverse function. Sine of arcsine is always x, as you can see here. Cosine of arcsine is square root of 1 minus x squared. Tangent of arcsine is x over square root of 1 minus x squared. Sine of arccosine is the square root of 1 minus x squared. Cosine of arccosine is x. Tangent of arccosine is square root of 1 minus x squared over x. And sine of arctangent of x is x over square root of x squared plus 1. Cosine of arctangent of x is 1 over the square root of x squared plus 1. Tangent of arctangent of x is equal to x. So can we do this? Let's compare each set with the triangle that goes with it. Here I'm looking, the inner function is arc sine of x. That means that an angle theta, whose sine is x. So I set it up as x over 1. Then I use Pythagorean identity to calculate the other side. And then I use this angle to find the cosine of theta and tangent of it. This triangle to find cosine of theta and tangent of theta. Over here, the second set, inner function is our cosine of x. And so it's for an angle theta, I have basically the adjacent over hypotenuse is x over 1. Use Pythagorean theorem to find the other side, 1 square root of 1 minus x squared. And then use the triangle to find sine, cosine, and tangent. Then over here, over the last set, inner function is arctangent of x. Set the triangle so that opposite over adjacent is x over 1. Use Pythagorean theorem to calculate the hypotenuse. Then find sine, cosine, and tangent of theta. And so all of those are done in a similar manner. And basically the other interesting part is that if you have if let's say x is not positive and x is negative value, the same formula works and you don't have to worry about the sign of it. Now let's get to derivative of inverse trigonometric functions. I cannot emphasize enough on memorizing these. They come back repeatedly in calculus 2. So let's say we can find the derivative of y equal to arc sine of x by implicit differentiation. So we drive one of them, but memorize all the formulas, and you can, for fun, drive all the other ones also. So let's start with y equal to arc sine of x. What do we mean by implicit differentiation? I don't know how to take the derivative of arc sine, but I know how to take the derivative of sine. So I actually write it as sine of y equal to sine of arc sine of x, which is x. Then from here, I take the derivative, remembering that y is a function of x. So we take the derivative of both sides, and it becomes cosine of y times y prime is equal to derivative of x, which is 1. Now solve for y prime. What do you get? You get y prime is 1 over cosine of y. Now go back to the triangles that we just drew, and y is the arc sine of x, and now we're finding cosine of arc sine of x. So what should cosine of arc sine of x be? And that is equal to square root of 1 minus x squared. And so you replace it there. Why did I need to do this part? Because I didn't want y in here, so I had to convert cosine of y to cosine of arc sine of x. Why did I do that? Because it's not really, the function is not really trigonometric functions anymore, because these two kind of cancel each other out in the trigonometric sense. And so basically not quite cancel each other, but in some way we know that the trigonometry will be washed out of it, and it will be just the ratio at the end. And so the end is going to be square root of 1 over 1 square root of 1 minus x squared, and that's the derivative of arc sine. Now formulas to memorize: derivative of arc sine of x is equal to 1 over square root of 1 minus x squared. Derivative of arc tangent of x is 1 over 1 plus x squared. Derivative of our cosine of x is negative 1 over square root of 1 minus x squared. And let's do a let's just match those with the graph of the functions. So derivative of arc sine of x is equal to 1 over square root of 1 minus x squared, and derivative of arc cosine of x is negative 1 over square root of x squared, and derivative of arc tangent of x is 1 over